G'day! In this lesson we'll be creating the server side, which includes the domain and the application layer. There is lots to do in this lesson, so let's get started. The domain layer in the startup template is separated into two projects, acme.bookstore.domain and acme.bookstore.domain.shared. The domain project contains our entities, domain services, and other core domain objects, whereas the domain.shared project contains constants, enums, and other domain-related objects. These objects can be shared with clients. We will first create our entity in the domain layer in the domain project. The main entity of the application is the book entity. We create a folder called books in the acme.bookstore.domain project, and we will then add a book class inside it. ABP Framework has two fundamental base classes for entities, aggregate root and entity. Aggregate root is a domain-driven concept, which can be thought of as a root entity that can be directly queried and worked on. Our book entity inherits from the audited aggregate root, which adds some base auditing properties like creation time, creator ID, last modification time on top of the aggregate root class. ABP automatically manages these properties for us. GUID or GUID is the primary key type of the book entity. We will leave the entity properties as public for the sake of simplicity. Now that we have our entity, we will create our book type enum. The book entity uses the book type enum. So let's create a books folder in the domain.shared project and add a book type class inside it, and we will replace its contents with the following code. We will now add the book entity to the DB context. EF core requires to relate entities with our DB context. The easiest way to do this is to add a DB set property to the bookstore DB context class in the entity framework core project. Now that we have our book DB set, we will need to map the book entity to a database table. Let's open the bookstore DB context model creating extensions.cs file in the entity framework core project and add the mapping code for the book entity. You will note that the bookstore constants has constant values for the schema and table prefixes. For our tables, we don't have to define any constants in the bookstore constants class, but it is suggested to control the table prefixes at a single point to reduce name collisions with other modules you may use. Configure by convention method gracefully configures and maps the inherited properties. We should always use it for all our entities. The startup template uses EF core code first migrations to create and maintain the database schema. Let's open the Package Manager console, PMC, under the menu, Tools, NuGet Package Manager, and let's add the database migration. To do this, we will select the DB migrations as the default project and execute the following command: add-migration created_book_entity. This command will create a new migration class inside the migrations folder of the DB migrations project. It's a good idea to have some initial data in the database before running the application. We'll use the data seeding system of the ABP framework to seed initial data into the database. Let's create a class deriving from the interface iDataSeedContributor in the domain project. We will paste the following code. This code simply uses read-only instance of the iRepository of type book entity with the type GUID, which inserts two books to the database, only if there are no books in the database already. Finally, we can update the database. To do this, we will run the DB Migrator console to set up the schema and seed the initial data into the database in our development and production environments. We will now build the application layer. In the ABP framework, the application layer is separated into two projects. The application.contracts contains our data transfer objects, DTOs, and application service interfaces. And the acme.bookstore.application project contains the implementation of our application services. We will now create an application service to get, create, update, and delete books using the CRUD App Service base class to the ABP framework. The CRUD App Service base class requires to define the fundamental DTOs for the entity. Let's create a books folder in the application.contracts project and add a book DTO class inside it. DTO classes are used to transfer data between the presentation and the application layer. The book DTO is derived from the audited entity DTO of type GUID, which has auditing properties just like the book entity we created before. We will need to map the book entity to the book DTO objects while returning books to the presentation layer. ABP Framework comes with the Auto Mapper pre-configured. Auto Mapper library can automate this conversion where we define a proper mapping. To do this, we will just define the mapping in the Bookstore Application Auto Mapper Profile class in the application project. We will also need to create a Create Update Book DTO. So, we also create a class for it inside the Books folder of the application.contracts project. This DTO class is used to get the book information from the user interface while creating or updating a book. It defines data annotation attributes like required to define validations for the properties. DTOs are automatically validated by the ABP framework. Just like we mapped the book DTO, we will define a mapping for the Create Update Book DTO object to the book entity in the Bookstore Application Auto Mapper Profile class in the application project. Now that we have our DTOs defined and mapped, we will define an interface for the application service. Let's create the iBook App Service interface inside the Books folder of the Application Contracts project. Defining the interfaces for the application services are not required by ABP Framework. However, it's considered to be best practice to have interfaces. The iCRUD App Service defines common CRUD methods like getAsync, getListAsync, createAsync, updateAsync, and deleteAsync. We are not required to use the iCRUD App Service interface. Instead, we can inherit from the entity iApplication Service interface and define our own methods manually, which we'll be doing when we create the application layer for the authors in the future lesson. Now it's time to implement the iBook App Service interface. Let's create a new class named Book App Service in the Books folder of the application project. Book App Service is derived from the CRUD App Service, which implements the CRUD create, read, update, delete methods defined by the iCRUD App Service. Book App Service injects the iRepository of book entity with the type GUID, which is the default repository for the book entity. ABP Framework automatically creates default repositories for each aggregate root or entity. Book App Service uses iObjectMapper service to map book objects to book DTO objects and create update book DTO objects to book objects. The Angular startup template uses the AutoMapper library as the object mapping provider. We have defined the mapping before, so it will just work as expected. In a typical ASP.NET Core application, we have to create ABP controllers to expose application services as HTTP API endpoints. This allows our browsers or third-party clients to call them over HTTP. ABP automatically configures our application services as MVC API controllers by convention. The Angular startup project is configured to run the Swagger UI using the squashbuckle.ASP.NET Core library. Let's ensure that the host project is set up as our startup project, and we will then run the application and navigate to localhost/Swagger in our browser. You'll see some built-in service endpoints as well as the book service and its REST style endpoints. Let's try and execute the API/app/book get HTTP endpoint to get a list of books. There we go. We can see that the server has returned 2 books in a JSON format from the database. In this lesson, we created the domain and application layer of the Bookstore web application. Join me in the next lesson to build the book list page.